Hey everyone, and thanks for tuning in again. In today's video, we'll be covering how to transform non-normal data. So, normality in the dependent variable will often be associated with non-normal residuals, and this violates one of our regression assumptions. As a result, this yields problems for inference. So, to try and eliminate non-normality, we can try and apply transformations before an analysis. So what we'll do in today's lab is we'll examine the skew and kurtosis of the variables in the regdata3 dataset. This is the dataset that we used in the last video. If any of these variables exhibit relatively large values for skew and/or kurtosis, we will try applying two different transformations. First, the square root, and second, a log transformation. And we'll be using the natural log, which is the default in most software. After transforming our variables, we will check for improvements by recomputing our descriptive statistics, where we'll look at the skew and kurtosis values, and by visually inspecting the transformed distributions using histograms. Before we get started, just want to make a note on interpretations. Remember that the standard interpretation for a regression coefficient is the expected change in y given a 1 unit change in a predictor controlling for all other predictors. This changes when variables are transformed because the units of y have changed. So instead of speaking in terms of a beta unit change in y, we will now be talking about a square root unit change in y, or a log unit change in y. Because it's not just in the units of y, but it's now in the square root of the units of y, or the log units of y, or whatever transformation you may be applying to your data. So just remember that the interpretation will change and become a little bit more messy when you transform your variables. And with that, let's go ahead and get started with the lab. Okay, so what I have open here is another template for week 8. It's titled week 8 _ template R. And so where we'll start is we'll read in our data. We'll be using the regdata3 dataset, so I'm going to create an object called regdata3, and then I'll go ahead and use read.table to read it in. Header equals true because the first line of the dataset are the variable names, and then the separator is equal to a tab. So I'll go ahead and run that line there. 150 observations, 5 variables, that looks good. Click on it just to check. Yep, this is the same data set that we were working with in the last video. So perfect. Okay. And so where we'll start is we'll examine skew and kurtosis for the variables using the describe function. So I'm going to load the site package, and then I'm going to use the describe function to get my descriptive statistics. So here I'll run I'll load the site package and then request my descriptive statistics. All right. So looking at skew and kurtosis, remember that a rule of thumb is plus or minus 3. Skew values that are exceeding 1 though could be problematic, but it just depends, and again, those are just rules of thumb, but at least it'll draw our attention to the variables that we should be looking at. Okay, so here, skew of 0.11 and 1.29, so nothing concerning there, nothing concerning for x2, nothing concerning here for y1. Y2 here, we have a kurtosis that's above 3, so 4.12, and a skew of 1.25. And then Y3, a little bit more non-normal, but not too bad. So we're going to focus on Y2 here. So the first thing we'll do is we'll inspect a histogram of the Y2 variable. So I'm going to plot from the regdata3 dataset. And remember, a $sign indicates that the variable is coming from a particular data set. So we have regdata3, the data set, $sign, and then the variable name, so y2. The next argument is main. I'm going to add a title. going to label the x-axis using xlab. Remember that the axis labels will be, it won't include this whole thing here, so it'll say reg data 3 $y2, and I don't want it to say that, so I'm going to change it to say just y2. And then I'm going to change the color to make it a little bit more exciting here to olive drab. Alright, so when I run this, I get my histogram, and I think we saw this histogram in the last video, but we'll take another look at it. And yeah, and so we see there's an observation out here, and so there does seem to be a bit of positive skew in this distribution here. Okay, so let's go ahead and transform our variables. But before we get to transforming, as you can see here for y2, the minimum is a negative number. And when we're square rooting or taking or transforming using a log transformation, negative values will pose a problem for that. So let's go ahead and shift the distribution by adding a constant so that we don't have any negative numbers. So the way that we'll do that is we'll create a new variable called y2 new. And remember, so I'm going to create this new variable called y2 underscore new. And then we have the $sign here, which connects this to the data set I want to put this variable in, which is our reg data 3 data set. And so what I'm going to do is I'm going to take the original y2, and I'm just going to add 3. And that will this will add 3 to every observation we have for y2. So I'll go ahead and run this. And then if we check our data set, we have this new variable called y2 underscore new. And if you go down here, you can see that the original y2 was 0.27, and now it's 3.27. The original y2 was 1.61 for the second observation, now it's 4.61. So we just added 3 all the way down here, and then we've created this new variable called y2 underscore new. All right, now let's transform our data using by taking the square root. So I'm going to create another new variable called reg data 3. So in our reg data 3 data set, I want to add a variable called y2 root. And then I'll use the square root function on y2 underscore new. Remember that we want to transform this variable here that we've shifted to the right so that there are no negative values. And then we can go ahead and run this. And then if we take a look at our data set, we have yet another variable. So we have y2 underscore root, which is just the square root of all of the values, here. So if we take the square root of 3.278, we'll get 1.810. So if you take the square root all the way down, you'll get this variable y2 underscore root. All right, now we'll apply the log transformation. So I'm going to create a new variable in my reg data 3 data set called y2 underscore log. And then using the log function, I will take the log of reg data 3. Remember, y2 new, the one with no negative values. I'll go ahead and run that. Check our data set again. And there we have it. We have y2 underscore log, which is the log. So if you take this value and take the log, we get this value. Take this value, take the log, we get this value. Okay. So we've transformed our variables. We have these two new variables, y2 root and y2 log. And so now we'll use the describe function again on reg data 3 to check the descriptives, or the skew and kurtosis values of the transformed variables. All right, so let's run this. And this is where we want to focus on here. These bottom two rows for y2 root and y2 log. So as we can see, originally, y2 had a skew of 1.25 and kurtosis of 4.12. And when we apply the square root transformation, almost no skew, and kurtosis has been decreased to 1.90, which is an acceptable range. When we look at the log, though, on the other hand, it actually looks worse. So we won't be choosing this log transformation here, but the y2, the square root of y2 seems to be helping us with eliminating the non-normality. Okay. So since we like the y2, the square root transformation best, let's go ahead and plot our new variable and see what it looks like. So I'm going to go ahead and plot y2 root. Again, I'm going to add a title. Alright, so this is going to be remember, this is the histogram of the square root of y2. I'm going to rename the x label, the x-axis label, square root of y2, and then change the color once again. Okay. So I'll go ahead and run this. And there we go. So our variable looks a lot more normal than how it looked when we started. And that was the goal of applying these different transformations. But what's really interesting is that we applied two transformations that are supposed to help with positive skew, the square root transformation and the log transformation, yet while one of them did well at eliminating some of the non-normality, the other one actually made it worse. So remember that transformations, there are many of them, and it's a bit of a trial and error process. And it should be done before running your analysis. So again, we'll just compare real quick. As you can see, this was our original plot, which was positively skewed, but then when applying the square root transformation, it seems to have become more close to normal. And so with that, that concludes the video on transforming non-normal data in R.